Welcome back to my YouTube channel. So today's LeetCode DCC question is furthest building you can reach. So what question is saying you are given an integer array heights representing the heights of the building, some bricks and some ladder. And we have to start our journey from building number 0 and we have to move to the next possible building using some bricks or ladders. So what question is saying we are given an array and some bricks and some ladders. So this array indicates the height of the building. Okay. So suppose we have a building like this. And initially we are at building number 0 and we have to reach the furthest building we can reach using this bricks and ladders. So how we have to use this bricks and ladder? So it is saying like if the current building height is greater than or equal to the next building height, you do not need a ladder or brick. That means if current building, suppose we are here and we want to jump to this building whose height is less than the current building height. In this case, we don't need any ladder or bricks. We can directly jump. That means cost to jump to the next building will be 0. Now, if the current building height is less than the next building height, so we can either use a ladder, one ladder or a bricks. How much bricks? The difference in the heights of the building. Suppose we are here in building number 0 and we want to climb to building number 1. So let's suppose the height of this building is 2 and the height of this building is 4. So what will be the cost to climb to this building? Either we can use one ladder or we can use two bricks because the difference between the height of the building is 2. So this will be the cost. Either we can use one ladder or we have to spend two bricks to climb this building. So what our task is to reach the farthest building using the given ladders and bricks optimally. So starting from index number 0, we have to reach to the farthest building using the given bricks and ladders optimally. So I hope the question is clear. Let's take few examples to approach this solution. So suppose we have building height as 2, 3, 5, 9, 11. And we have one ladder and 5 bricks. So let's draw the building. So suppose we have, this is 0th index, 1 index, 5, 9, 11. So height of this building is 2, 3, 5, 9, and 11. This is 0th building, 1, 2, 3, 4. Currently, we are at this building. Now, in this example, we will try to first consume the ladder first and then we will move to bricks. So from building 2 to 3, from building number 0 to 1, so do we need to incur any cost to climb this building? Yes, because the next building height is greater than the current building height. So either we can use, so what will be the cost? The cost will be one ladder or one brick. Suppose we consume one ladder. So after using one ladder, we are left with 0 ladders and 5 bricks. So now suppose we are here. Now to move next building. So what will be the cost? So either again we can use one ladder or two bricks since the difference between the height of the building is 2. So since we are not left with any ladder, we have to use the bricks. So suppose we use two bricks. Now We are left with 3 bricks. Now we are here. Now what will be the cost to jump from building number 2 to 3? So the cost to jump is either one ladder or we need 4 bricks. Can we jump from building number 2 to 3 given we are left with 0 ladders and 3 bricks? No, neither we have one ladder nor we have sufficient bricks to climb the building. That means if we consume all the ladder first and brick first, we will be able to reach till building number 2. So is this the optimal solution? Means is this the optimal or the farthest distance we can reach using this one ladder and 5 bricks given the height of this building? I don't think so. Because if we see, we have used one ladder here. If we have used this ladder here instead of building number 0 to 1, if we have used that ladder here to climb building number 2 to 3, suppose we are not using this ladder here and we are using this ladder here. Okay. And instead of using this ladder here, we have used one brick. So suppose we are not using ladder here, that means we will left with one ladder. And suppose we have used one brick, so we will be left with 2 bricks. Now in this, when we will reach here, so we can easily use one ladder to climb this building, right? And from 9 to 11, the cost is one ladder or 2 bricks, right? And again, we have sufficient bricks to climb this building also. That means we could have reached building number 4 if we have used the ladders and brick efficiently. But if what we have seen, if we use ladders first and then we try to spend bricks, then it will not give the optimal solution always. So let's take one more example. So suppose we have 2, 6, 8, 10 with one ladder and 4 bricks. So in the previous example, we have used ladder first and then bricks. So in this example, we will try to use bricks first and then ladder. And we will see whether we are reaching the optimal solution or not. So the height of this building is 2. This building is 6. This building is 8. This building is 10. So suppose initially we are here. This is building number 0, 1, 2, 3. Suppose we want to jump from building number 0 to 1. So what will be the cost? Either we can use one ladder or we can use 4 bricks. So in this example, we will try to consume all the bricks first and then we will move to ladder. So do we have sufficient bricks to climb? Yes, we have. So once we climb this building, we will not be left with any bricks. So the bricks remaining will be 0 and we are here. Now to jump from building number 1 to 2, what will be the cost? Either we should have one ladder or 2 bricks. So since we are not left with any bricks, we are forced to use one ladder. So we will use this ladder and we are not left with any ladder. So now we are here. Now to jump from building number 2 to 3, what will be the cost? Either one ladder or 2 bricks. So since we are neither left with any ladder nor bricks, that means if we use brick first and then ladder, we will be able to reach to the maximum of 2 building number 2, given this example. But is this the optimal solution? No. If we see in the first case where we have used the brick first, if we have used the ladder here instead of bricks, so suppose in this first instance, we have used the brick first. So we will again be left with 4 bricks and 0 ladders. And suppose we have used ladder here. And in this case, we have used bricks. So we will left with 2 bricks And again, from 8 to 10, we can easily use two bricks since we are left with two bricks. That means there is no greedy approach to this solution, like where we can use ladder first and then brick, or brick first and then ladder. So given this two example, we can easily say like there is no greedy solution or greedy approach to find the optimized answer. So does that mean we have to follow the recursive solution? Like to jump from one building to another, we have always two options. And we are not sure at the current moment whether we should use brick or ladder climb this building. It may turn out like suppose we used bricks, and it may turn out later that we should have used the ladder. And if we have used the ladder, it may turn out that we have used the bricks here. So at every instance, we could have two options, either ladder or brick. So we can use the recursive solution to reach the maximum, to find the furthest building we can reach. So at every moment we will be using one ladder and the difference of the bricks. So once we are not left with any ladder or brick, then we can say like this is the maximum. But given the constraints, if we see the constraints given, the height of the array length is 10 to the 5 and the bricks count is 10 to the 9, and the number of ladders was given is maximum 10 to the 5. So given the constraint, if we use the recursive solution, the time complexity of the solution will be exponential, right? It will be exponential. Even if we try to memorize the solution, we will we don't have sufficient space. It will either give MLE or runtime error. We are not supposed to use that much of space. Given this constraint, we will not be able to store that many results and memorize the solution. That means we cannot use dynamic approach also. Then what can we think of? So if we understand the question carefully, we can see like suppose we have one building and two building, and in another scenario, suppose we have one more building and one more building. Let the height of this building is 2, 3, 50, and this is 10,000. Okay. So if we are using ladder in every case, so in this case, how many ladders it will be required? One ladder. In this case, one ladder. In this case also, if we use ladder, we need only one ladder. That means when we are using ladder, it doesn't matter what is the difference in the height of the building. But if we use brick, we need one brick here. We need 47 bricks here, and we need 9,950 bricks here. That means we are not worried about the ladder. If we use the bricks only optimally, we can reach the optimal solution. So our foremost task is to use the bricks efficiently. So let's take one more example. Suppose we have to height 2, 5, 7, 9, and 10. with 5 bricks and one ladder. Let's draw the building. 2, 5, 7, 9, 10. The height of the building is 2, 5, 7, 9, and 10. The index is 0, 1, 2, 3, 4. So at any particular instance, so we are not sure whether to use bricks or ladder, because it may happens like if suppose we have used bricks, then it may happen like we should have used a ladder in that case, because we will be left with more number of bricks and we can use that bricks in future. Maybe the jump in future is very less, or we could have used ladder here because in the future we could have used bricks here because in the future the height of the building is very high, so we could have used the ladder in that case. So we are not sure, right? So suppose I have one approach in my mind. Suppose we will be using bricks first, right? Suppose in this case the cost is 3 bricks or one ladder, and we have used 3 bricks, so we'll be left with 2 bricks. Now we are here, so here we need 2 bricks and one ladder. We will use 2 bricks. Now we will see, now we are here. Now we will see we are not left with any bricks and only one ladder. So now to jump from building number 7 to 9, we will see like we need either one ladder or 2 bricks. Since we are not left with any bricks, we are bound to use one ladder, right? There is no other option left other than to use this ladder. But if we see in the past, since we are bound to use we are bound to use this ladder, can we check in the past whether we have used that ladder in that scenario, in that instance, and we would have left with more number of bricks? Suppose here we have used 3 bricks, here we have 2 bricks, and in this scenario we require 2 bricks. So instead of using this ladder here, if we would have used this ladder in this scenario, and we have used this 3 bricks to jump this building, still we will be left with 1 brick, right? So, so how we can go in the past and check whether we can have used this ladder in the past and we would have left with more number of bricks after climbing this building also. Now, if we could see to climb from building number 3 to 4, we need only 1 brick. So this is the optimal solution. So our main task is to, at every instance, we need to check in the future, whenever we are using the ladder, in the past, we go and check whether we would have used that ladder in the past and end up saving more number of bricks. So how we can do that? So let's draw this example again. 2, 5, 7, 9, and 11. 9 and 11. So whenever we are using the bricks, so in this instance, we see that we need one ladder. If we use 3 bricks here, 2 bricks here, and one ladder here. So instead of using one ladder here, this is 10. Instead of using one ladder here, we could have used this ladder here. So why we thought of using this ladder here only in building number 0 to 1? Why not in building number 1 to 2? Because if we are using a ladder, we should have swapped with that jump in which we have consumed more number of bricks, right? Because anyway, if we will use the ladder here, we will save only 2 bricks. But if we will use this ladder here, we will save 3 bricks. And if suppose there are one more jumps, suppose we have one more jumps like here, and the height of this building was 1, right? So to jump this building, we would have used 1 brick, suppose. So if we use this ladder in this scenario, we would have we end up with 1 more bricks. So which is the best possible instance to swap the ladder? So this is the only best possible instance, right? Because if we will not swap the ladder with any of the past instances, we will use this ladder here to jump to next building. Otherwise, we will not be able to move further. So if we are using this one ladder here, why not we should use this ladder in any of the past instances, which will give me more number of bricks. So we will check in the past and see, is there any instance where we can swap this ladder and will end up saving more bricks. So what we can do for this? So whenever we will be using a brick, we will take a priority queue, right? So how only this data structure will help us to give the maximum. We are worried about the maximum number of bricks which we have used in the past. So every time we need maximum, right? Every time we need maximum bricks which we have used in the past. So, so suppose if we are moving further and every time we are using the brick, every time we are using the brick, we will move into priority queue. Suppose we use 2 bricks here, we will move in the priority queue that at particular instance we have used 2 bricks. And suppose we have used 4 bricks here, we will move this to priority queue. So 2, 4. So in priority queue, we will always get the maximum element. That is in case of max heap. If we use max heap, suppose we used uh, 4 bricks, 6 bricks here. Again, we will move that to the priority queue and we will keep updated like the maximum bricks we have used in particular instance is 6. Suppose now we are forced to use one ladder here. Then we can easily pop an element and see the maximum we have used. And suppose the height of this building difference is 4. So we can see the maximum bricks we have used at particular instance is 6. That means if we are bound to use a ladder here and we swap this ladder with this instance, we will end up saving 6 bricks. And out of this 6 bricks, if we use 4 bricks here, still we will be left with 2 further bricks to jump from this building to next building. So, so once we will swap this ladder with this bricks in the priority queue where we are storing, we will pop out the 6. We will pop out the 6 and we have used 4 bricks here, right? We will again move this 4 inside this priority queue. So this is the approach we will follow. So let's write the solution. Let's find the size of the building. So n indicates the number of buildings we have and priority queue, which will help me in storing the instances where we have used the bricks. Let's name it maxit. Okay. Now, initially we are at building 0, right? So we will start from building number 1 till n. Now we will check if current building height. If height of current building is greater than height of previous building, that means we need a brick or a ladder to jump. So first we will check whether we have sufficient bricks or not. So now if we have sufficient bricks, this many bricks are required. If this is less than equal to the bricks, that means we have sufficient bricks to use and we can reduce the bricks. This many bricks we will use, and in the max heap we can store that this many bricks we have used at a particular instance. If we don't have sufficient brick, that means we are bound to use the ladder. Then we will see whether we have the ladders or not. If we have ladder, then we will see in the past, we will go in the past and check whether we have used more number of bricks than the current instance in this scenario. In this scenario, we need I minus heights I minus 1 number of bricks if we don't use the ladder. So we will go in the past and check, and past into max heap dot top. This will give me the maximum number of bricks we have used in the past at a particular instance. So we will check if the past is greater than current instance, the number of bricks required currently. If this is greater, that means if we have used the ladder in that scenario, in that past tense, we would have end up with more number of bricks. So how many bricks we will be end up? So past plus, so this many bricks we will be left with. And we have to reduce one ladder. Else, if we don't have sufficient bricks nor ladder, that means we cannot move further and we have to return the position of the current. That means the last position of the building where we have reached. If we have covered all the buildings, that means we have reached the end of the building. I hope this solution works. Let's check. Yeah, sample test case is passed. Let's try to submit the solution. There are some null pointer exception. Yeah, correct. So we are trying to which we are trying to find the top of the element without checking whether we have any instances in the max heap or not. So first we have to check whether max heap is empty or not. If it is not empty, and also then only we can do a top operation. If max heap is not empty, then we will find the past element which we have used, the maximum past instances. And if past instances is higher, that means we have to pop that element from the max heap and we have to push the current instances what we are using and the current difference. That means we have popped the we have used the ladder in case of this instances. That means we have saved this many of bricks. That's why we are popping. And instead of in the current instance, instead of ladder, we are using the bricks which we have gained on using the ladder in this case. So we are using height I minus 1 bricks, and we are left, and the remaining bricks what we are left with, we are added in the cumulative bricks. So I hope this solution will work. Yeah, now the solution is accepted. Meet you in the next video. Thank you.